If we do all this, then what we're doing is we're constructing what we're going to call a Riemann sum. Okay, so how does that work? Well, we have this region, this is constructed as we said before. First thing, we're going to slice it up. Okay, so what we're going to do is we're going to decide on what width we want, and again we're going to assume that the delta x is equal to the total width divided by n. Remember, that's not necessary, we're doing it just to keep things simple. Okay, then what we're going to do is we're going to approximate the area of each of those slices by using rectangles. So what that means is, first of all, we're going to decide which values we're going to pick. So we're going to pick some value, one value in each of those strips. Okay, and then corresponding to those values, we're going to figure out how much the value of the function is. Those values that we picked, x1, x2, x3, could be close to the middle or could be closer to one of the edges or the other one. It doesn't matter. All we have to do is just pick one x value in each of those strips. Later on, we're going to give some names to some of the choices that we're going to make. At this point, what we're going to do is, again, for each one of those xi's, we're going to be able to compute f of xi. That's going to be the height of our rectangle. Okay, so what we're going to do is going to construct all these rectangles built according to our choices. Next, we're going, and then of course the area of each one of those rectangles is going to be equal to the product of delta x, which is the base, times f of xi. So pretty much what we had before. And finally, we're going to add up all those rectangles. So the area is going to be approximately given by the sum from 1 to n of f of xi delta x. Okay, now keep very well in mind these three steps: slice, approximate, add up. There is a fourth step that is coming in the next class, and those four steps will come up over and over again in all kinds of other applications of what we're about to build. And probably, since you have already done Math 31, you know we're building integrals here, right? So that's coming soon. But keep in mind, those are the first three basic steps of this construction, and you want to be very clear about what they mean and what each of those pieces of the notation mean. As I showed you what the Riemann sum looks like, I mentioned that we have to pick one value in each of the intervals, in each of the strips, and we can pick them any way we want. So we have choices. Some of these choices have special names. For instance, if I pick the left end point of each of those intervals, like I'm doing now, I'm going to call this a left Riemann sum. And that will be the sum from 1 to n of f of xi delta x. For obvious reasons, it's called the left Riemann sum, right? If I pick the right endpoints on each of those intervals, like these points here, then I'm going to end up with the right Riemann sum. What I can do is I can also pick for each interval the highest, the point that gives me the highest value of the function. Okay, so in this case, I'm going to call this the upper Riemann sum. So this is the biggest Riemann sum I can get with those strips. Okay. Now notice that in this situation, sometimes you may have two values which can actually be very close, or in some situation can be exactly the same. Okay, so we're not going to, that's not going to be a problem, and if we end up with two values in the sum that correspond to the same x, that's still okay. In the same way, what I can do is I can pick in each of the intervals the value which gives me the lowest value for the function. Okay, and again you can see that sometimes those two values can come very close or maybe even equal to each other. Okay, in this case we're going to talk about a lower Riemann sum. Now these again are just some choices that have some special names. There are others that have special names. You're going to see one in the example coming up. Okay, but more generally, again, there are other choices. I can pick each one of the values in each of the intervals any way I want, as long as I pick one point, one value in each of the strips, and I compute the corresponding value of f.